of dissolved oxygen required to oxidize the organic compound by living organism in water sample, which occur at certain temperature over a specific time period. Here, the organic compound oxidizes by CO2 and H2O.
The objective biological oxygen demand (B.O.D) test to measure the strength of the industrial wastewater using oxygen utilized as a stability factor, then to determine the dissolved oxygen (DO) and B.O.D of a wastewater sample.
B.O.D test, and we'll be using B.O.D bottles, B.O.D incubator. Sample we'll be using for our B.O.D test is sample number 1, phosphate buffer, sample number 2, magnesium sulfate, sample number 3 is calcium chloride, and sample number 4 is ferric chloride.
Is total suspended solid. Total suspended solid can call T.S.S. What is T.S.S? T.S.S are particles that are large than 2 microns found in the water column, and they comprise organic materials like clay, sand, minerals, and metals. They are also include bacteria and algae and virus. Suspended solids particles are large enough to settle curiously. That substance in particle are responsible for turbidity and color.
The objective total suspended solid test (TSS test). This objective of the experiment is to determine the quality of suspended solids in polluted water samples. And water quality is vitally important in our daily life. However, due to water pollution, the quality of water is questionable for safe usage.
Will be total suspended test. We'll be using glass microfiber filter disc, disposable aluminum dishes, suction flask 1000 ml, 47 mm glass microanalysis filter golder, drying oven for operation at 103 to 105 temperature, desiccator, analytical balance which is capable of weighing to 0.1 mg. Lastly is our distilled water.
For the theoretical procedure, firstly, the preparation of the glass fiber filter disc, insert the filter onto the base and clamp the funnel. While vacuum is applied, wash the disc with 3 successive 20 ml distilled water. Remove all traces of water by continuing to apply vacuum after water has passed through. Remove the funnel from base and place filter into the aluminium dish and fry in oven at 103 degrees Celsius to 105 degrees Celsius for 1 hour. When needed, remove the dish from the oven, desiccate and wait. And then number 2, select a sample volume maximum of 200 ml that will yield at not more than 200 mg of total suspended solid. And next, we place the filter on the base and clamp on funnel and apply vacuum. Wet the filter with a small volume of distilled water to seal the filter against the base. Fourth, rinse the pipe and funnel onto the filter with small volume of distilled water. Remove all traces of water by continuing to apply vacuum after water has passed through. Fifth, shake the sample vigorously and quantitatively transfer 100 ml of sample to the filter using a large orifice. Remove all the traces of water by continuing to apply vacuum after sample has passed through. And lastly, carefully remove the disc filter from the base. Dry for at least 1 hour at 103 degrees Celsius. Cool in a desiccator and wait. For the experimental procedure, firstly, we must prepare for the filter, which is wake the glass fiber filter before starting sample filtration. Constantly wait the weight loss less than 0.5 mg. And number 2 is sample filtration, which is we shake the sample and transfer the sample to a graduate cylinder. Third, we place the pre-weighed filter and filtration apparatus and wet it with a small volume to distilled water to fix it. Then we pour sample into the filter holder and we repeat rising both graduate cylinder and funnel with distilled water for 3 times. Next up, we keep running the pump until drainage the residual distilled water out the funnel. Fifth, we turn on the pump. After that, we transfer the filter to the aluminium dish. And then we place the filter in an oven and dry it for at least 1 hour. Transfer the filter into the desiccator and cool it into room temperature. Lastly, we wake the filter after it cooled down. We repeat the step 9 to 10 until obtain the constant weight. And we calculate using the formula of the weight of filter and residue in gram minus the weight of filter, and then we times 1000 and we divide by volume of the sample filter. Thank you.
What is alkalinity? Alkalinity is the measurement of the buffering capacity of the body water, that is, a body of water resistant to the lowering of pH when acids are added to the water, and the result of minerals that dissolve from rocks and soil as water flows through them.
Objective alkalinity test. The pH of water determines what type of alkalinity can be found in the water. By performing 2 different alkalinity tests with different endpoint pH values, we are able to estimate the proportion of carbonate, bicarbonate, and hydroxide alkalinity in the water. The 2 tests also help us determine whether the water is corrosive and whether it is caustic.
Alkalinity test will be using pH meter, red, measuring cylinder, beaker, magnetic stirrer, hot plate stirrer, hydrochloric acid, and distilled water.
First, rinse pH electrode and 150 ml beaker with distilled water. And second, transfer 100 ml of water sample into the beaker. Step 3, dip pH electrode into the sample. And number 4, stir the sample with a magnetic stirrer. Be sure that pH electrode tip near the beaker bottom without touching the rotating magnetic stirrer. And number 5, record pH when constant reading is obtained. For step number 6, add HCl hydrochloride about 0.02 ml using burette in increment of 0.2 to 0.5 ml into the beaker. And number 7, after each addition, mix the solution truly but gently with the magnetic stir, avoiding splashing. Number 8, record pH when a constant reading is observed. And number 9, continue adding tyrant and measure pH until pH 4.0 is reached. Step number 10, obtain data should be recorded in a suitable table and construct a deterioration curve by plotting observed pH value versus cumulative milliliters tyrant added. And number 12, from the curve, obtain the volume of hydrochloric added when at pH 8.3 and pH 4.5. Compute the alkalinity value for both volume of HCl from step 12 in ppm of CaCO3. Now the step during the experiment in the lab. First, rise pH electrode and 150 millimeter beaker with the distilled water, and then transfer the 100 ml of water sample into the beaker, and then dip the pH electrode into the sample and stir it with the magnetic stirrer. pH electrode. Make sure the pH electrode tip near the beaker bottom without touching the rotating magnetic stirrer. After all, record the data when the volume obtained is constant, and then add HCl hydrochloride in 0.02 ml using the burette increment of 0.2 to 0.5 ml. Observe the data until the value constant and record it, and continue adding tyrant and measure pH until reach pH 4.0. Then plot the data obtained should be recorded in a suitable table. Construct the tyrant curve by plotting observed pH value versus cumulative milliliter tyrant added. And then from the curve, obtain the value of HCl when at pH 8.3 and also pH 4.5. And compute the alkalinity value for the both volume of HCl from the previous step in a ppm of CaCO3. For this experiment, we also can use the formula of converting HCl molarity to normality. And this slide show the alkalinity, how to change the ppm CO3 by this formula given.